Hello and welcome back to Scale Me Down and to another episode all about this Pilatus PC6 Turbo Porter with variable pitch propeller. In the last episode we decided we needed some new propeller blades with reduced pitch. And so here we are, I've 3D printed a brand new set of 3 in PLA Plus, all sleeved and balanced, ready to go. Just a reminder of how we got here though, and before we fit them, remember to like and subscribe to support the channel. I redesigned the blades with 5 degrees less pitch and then reprinted them one at a time in tougher PLA Plus. Roughened and cut some new brass sleeves, grinding them all to the same length before fitting them with JB Weld epoxy. So, 3 new blades fitted, let's see if they work. Let's start with some taxiing. It looks as though we've solved that vibration problem we found in the last episode. Ground speed is now completely controllable using propeller pitch in ground mode. These new propeller blades seem much better. In fact, good enough to try a maiden flight. The propeller slipped on the shaft again, so we stripped it down and retightened everything before trying again, this time without the upper cowling and spinner. However, once again the propeller slipped on the motor shaft, although the acceleration at maximum pitch was very impressive. We were running out of daylight really, so after retightening everything, I reduced the maximum propeller pitch to prevent it from keep slipping, just to see if this thing would ever fly. I gently coaxed our plane around one circuit, being as gentle as I could on the pitch lever, just to get an initial idea for the trims, centre of gravity and control throws, and I've got to say the handling and control harmony was very nice. My first impressions of the tail surfaces that we scratch built in episode 2 are that the section and incidence seem appropriate and the plane seems quite stable in flight. On landing, I accidentally touched the propeller on the ground. That looked a lot worse than it actually was. I just touched the propeller just on the ground and the blade grip failed, as you would expect. But other than that, let's get it back to the workshop and have a look at it. Now we're back in the workshop, it really isn't that bad. Obviously, we're going to need to replace the blade grips, and whilst we're at it, we'll strip the motor and propeller unit down, and I'm going to ask my friend Mark to put a grub screw in this boss right here and a flat on the motor shaft to prevent the propeller from slipping on the motor shaft. Actually, most of the damage occurred on the ground at the end of the landing roll and was caused by the vibration when one of the blades came off. The good thing is it didn't shake itself to bits. However, we do need to print a new tailwheel bracket. That's no big deal, but the most disappointing bit were the wing struts. Now, come on VQ models, as supplied with the kit, these have little tin plate ends and the metal's very thin and it fatigued with the vibration and broke. So we'll put some proper ends on these. Let's make a start on the repairs. So first, over to Mark's workshop to make some modifications to the propeller boss. Here he's setting up his milling machine using an edge finder so that it can drill a centred hole right across the hub. This was then tapped for an M4 grub screw, which, when tightened against a milled flat on the motor shaft, should prevent the propeller boss from slipping once and for all. Then I could refit the motor, including the shims, to ensure that all the bearings lined up for the pitch change rod. And then refit the propeller hub, tightening the set screw we just fitted. I reassembled and refitted some new blade grips. And then I had to make and refit a new pitch change rod assembly. All working smoothly again so I could refit all the cowlings. And then refit the propeller blades. When I removed the covering from the damaged struts, all I had to do was drill out this rivet to remove the ends. I replaced the ends with bent 1/8 aluminium, which I epoxied into position and secured with bamboo cross dowels. Now let's move on to the landing gear, and let's 3D print a new tailwheel bracket to replace the damaged one. As before, this was reassembled with 2mm threaded rod dowels and CA glue. I think we need to improve the clearance between the propeller and the ground. And to do that, I've drawn and 3D printed some new wheels. And these are more true to scale, like the Tundra wheels and tyres often fitted to this type. What we need to do now is make some tyres to fit them. And hopefully the improved clearance will prevent further prop strikes. I started by cutting out some tyre blanks on our laser from this scrap packaging EVA foam. I had to cut it in 3 low power passes to get a good cut and avoid melting the foam. Two thicknesses were required and contact glue was used to bond the layers together. I used a nut and bolt to chuck the wheels up in my drill in order to carve the tyre profile using a Permagrip block. This revealed some of the open cell foam structure, so to seal it back up I brushed on 2 coats of this foam armour from Deluxe Materials. And whilst that dries, let's press the 3/16 bearings into the hubs. Once the foam armour was dry, I gave the tyres 2 coats of this rubberised truck bed liner paint. Yoo-Hoo Pour secures the tyres to the rims. Here we are with our new wheels fitted, and you can see there's much improved ground clearance. The wheels look super blingy and scale-like and free running on their radial bearings. And hopefully that should avoid further prop strikes. I'm really looking forward to trying again next time, as we're nearly there, although we're running out of time in this episode. But if we are more successful on the next flight, we're going to fit some more scale features, such as these modified cargo camera pods. And we've mounted our run cams to these, and they mount underneath the wings in the scale positions, so we should get a better look of the mechanism in flight. As ever, Thanks for watching, stay tuned, and we'll see you next time in the next episode.